welcome back. Or maybe you didn't go anywhere. I don't know. Whoop. Second video. So, time to actually talk about the process of transcription. I'll say it again in case you're lost. Yes, we did this on Friday. If you were here on Friday, don't watch this video. You should be watching videos 3 and 4. You should be down here with the genetic code stuff. So, if this is like, I already know this, fine. Fast forward. Go to video 3 for the genetic code. Go to video 4 for translation, all right? But if you weren't here on Friday, or if your notes are blank, you need to be right here at video 2. You're in the right spot. All right, so transcription. We're going to abbreviate that one as DNA is used to make RNA, the first step in the genetic code. Guys, I like these abbreviations. You'll see them a lot. I've got one for every process. Replication, remember, was DNA used to make DNA. Now, the location is important. To do transcription, we've got to go to where the DNA is, which by now, hopefully I've taught you well enough you know, is the nucleus. Anything involving DNA, so transcription, DNA to RNA, and DNA replication, DNA turned into more DNA, has to take place here. Okay? Translation is RNA to protein. It'll happen someplace else. The main enzyme involved is RNA polymerase. Polymerase is just a fancy name for maker. So this is the enzyme that makes RNA. There's also an enzyme we learned about last week called DNA polymerase. DNA polymerase makes DNA. But today we're doing transcription, so we need to make RNA. Both enzymes work kind of the same way. They read the DNA and use the base pairing rules, A pairs with U, C pairs with G, to make the new molecule. So G pairs with C, T pairs with A pairs with U, G with C, the C will get a G eventually. You get the idea. Okay. So RNA polymerase has an easy job. Transcription occurs in 3 steps. I love these steps. The names make sense. That doesn't happen nearly often enough. Step 1 is initiation. Initiation means start. We start making the RNA. Step 2 is elongation. Elongation means make a nice long RNA. Step 3 is termination. Termination means stop. So when you're done, you stop. Love it. It makes sense, which means it fits in our heads better. Okay? Now we're going to go into a little bit more detail in these steps. Initiation begins at the promoter. Promoter here. Okay? The promoter is kind of like a capital letter in a sentence. It indicates this is where my sentence begins. Start reading here. So RNA polymerase starts right there. Then elongation occurs. Elongation, the RNA polymerase, it moved. That's that kind of green blob that keeps moving. That green blob is the RNA polymerase. It reads the DNA. G pairs with C, T pairs with A pairs with U, and creates an appropriate RNA. So the red is RNA, the blue is DNA. Right? Notice it's strands. Double-stranded, single-stranded. Just one little line of RNA. All the stuff we learned is right. Third and final step is termination. Termination means stop. So we hit the terminator. Can't do an Arnold Schwarzenegger accent. Terminator's down here. Think of it as the period at the end of the sentence, saying we are done. Everything in between the promoter and the terminator has been turned into RNA. So we are complete. Our job is accomplished. So there's one question in your notes about this. That question is, what's the difference between a promoter and a terminator? Promoter here, terminator there. So hopefully you can figure it out. The promoter marks the beginning of the gene, or the start, and the terminator marks the end of the gene. Never said it was complicated. Now on a test, you will get a sequence of DNA, and I will ask you to transcribe it into RNA. There's two ways of doing this. You can do it letter by letter, go in order. Some of my students, especially those with dyslexia, find it easier to do it letter by letter. So T pairs with A. We've learned that. So guys, under every T, write an A, because that's always going to be true. A, this is the weird one, A pairs with U, because there's no T in RNA, so A's are weird. Under every A, write U. Okay, C pairs with G. The two round ones go together, so C, G, C, G, C. Oof, lots of C's. G, oh, one more. And then finally, G pairs with C. We get the same exact answer as if we'd gone in order, but order is boring. And some of you might find that easier. So do whatever works best for you, just as long as you can give me an RNA sequence. Okay? Oh, we're done. I'm back where I started. So that was video 2. Now you're ready for video 3. Go ahead and move to that one and see you there.